Hi guys, here are the answers to the negative exponents homework. I'm going to kind of talk through each problem in case you had questions on them, but feel free to fast forward to particular questions that you had trouble with. All right, I'm just going to make my pen a little smaller, and I like purple. Okay, so number one, you have 4 to the negative second exponent. So remember, you put it over 1. We can flip it, so it's 1 over 4 squared, and then you can do the math on that because 4 squared is pretty simple. So you can get 1 over 16. All right, negative 5 to the negative third, put it over 1. I'm going to flip it to the positive third exponent, and I can leave it like that, or negative 5th to the third exponent. You can multiply that one out easily. You're going to get negative 125. Okay, number 3. So this one was designed to trick you. Remember, the integer or the base is actually negative in this case, not the exponent. So we're not going to do any flipping. Okay, don't let that negative trick you out in front. So I would accept if you just left it like this, or you could do the math here. You could do 5 to the third power, which is 125, and then make it negative to get to negative 125 for your answer. All right, number 4, we can put it over 1, flip it, the exponent can become positive, and you can just leave it like that. Number 5, anything to the 0 power is 1, so this actually just equals 1. Number 6, I'm going to flip. And if that exponent becomes positive 1, we don't even have to write it. We can just leave it like that. 7, flip. And that's your answer. Number 8. Okay, remember, look at each part when you're deciding to keep or flip. 5 has a positive exponent of 1, so we're going to keep it. X to the negative 4th, that's got the negative exponent, so we're going to flip it. There's your answer. Okay, number 9, same thing. Look at each part. I'm going to do it down here. 11 has a positive exponent, so leave it alone. Y has the negative exponent, so flip it, and it becomes positive. Okay, number 10, look at each part. Negative 3 has a positive exponent, so leave it alone. And then the R we're going to flip and make the exponent positive. Okay, number 11. So y to the 0 power, that's just going to equal 1. And each piece of this, they both have positive exponents. So just 3x would be your answer. Okay, number 12. All right, the x to the negative second, we're going to flip, becomes positive. Y to the negative 5th, flip, becomes positive. And then we have to put the 1 in the top. Okay. All right, second section, write each expression using a negative exponent. So we're going in the opposite direction. So if it's in the bottom with a positive exponent, we can flip it to the top and it becomes negative. All right, in the bottom with the positive exponent, flip it to the top, it becomes negative. Number 15, our 4 already has a positive exponent, so just leave it alone. And then the x, we're going to flip it up to the top and it becomes negative. And number 16, let's just keep the x squared positive, and we're going to flip the 5 to the negative third up top. Okay, you technically could take these last two a step farther. We could take this and make it have a negative exponent by flipping it into the bottom, because remember, the exponent goes to the opposite when you use the reciprocal. So you technically could say 5 to the negative third over x to the negative second. Same thing with this one. This really means 4 to the positive first power. We could technically flip both of these. Whoops, not to the third. We could flip both of these to make the exponents negative. So you could technically write that also. Okay? All right, number 17. So here we're multiplying. So you're going to keep the base and add the exponents. So 3 plus 2 is 5. Number 18, raising a power to a power. Keep the base, multiply those exponents. So b to the 8th. 19, power to a power. Take each part and raise it to the third power. So 4 to the third power. 4 times 4 times 4, 64. Then take f to the negative second to the third power. Keep the base of f. Multiply the exponents. We're not done because the directions say only positive exponents. So I'm going to put this over 1. 64 has a positive exponent, so I'm going to keep it. And the f is going to flip and become positive. Okay, number 20, division problem. Keep the base of -2, subtract the exponents, we get to the fifth power. You're done because you have positive exponents. All right, 21, I'm going to keep 5 to the 6th. I'm going to do the math on the bottom. Power times a power, so I'm going to keep the base of 5. I'm going to add 9 and 4, which is 13. Now I'm going to do my division. So 5 to the 6th divided by 5 to the 13th, I get 5 to the -7th. I have to write with a positive exponent, so I'm going to put it over 1, and I'm going to flip and make the exponent positive. So 1 over 5 to the 7th. Okay, the next one is very similar. I'm going to keep x to the 14th. I'm going to add the exponents in the bottom because it's multiplication. Now I'm going to divide. So I'm going to keep my base of x. I am going to subtract the exponents. So think 14 minus -2. Integer rules, keep, change. So I actually get x to the positive 16th. And since it's positive, I am done with that one. All righty, 23. So I am going to multiply across the top. So that means I'm going to add my exponents. I get y to the 20th over, and then add the exponents in the bottom, y to the 24th. Now I'm going to divide. So I keep my base of y, I subtract, so I get y to the -4th. I got to rewrite this, so I'll put it over 1. I'm going to flip and make that exponent positive. Okay. All right, 24. So 3 and 9 are coefficients. I am going to just reduce that to 1/3. Then I'm going to divide my like bases of x. So I keep the x, I subtract the exponents, I get to the -4th, and then my y will just stay y. Okay, so here is that fraction bar. Okay. Remember, if it has a positive exponent, leave it alone. If it's got a negative, it's going to flip. So here I have 1, it's positive, leave it alone. Here I have 3, it's in the bottom, but it has a positive exponent, so just leave it alone. X to the -4th, it's negative, so we're going to flip it to the bottom. And then y has a positive exponent, so it can stay. All right, so you could leave your answer like this, or 1 times y is just y. And then you would have 3x to the positive 4th in the bottom. Okay. 25, we're going to raise our power to a power first. So I'm going to think 4 squared, and that's going to give me 16. Then I'm going to think a to the 3rd squared. So I multiply the exponents, I get a to the 6th. And I'm going to divide that by a to the 5th. So I'm going to keep 16. And then keep the base of a, subtract the exponents, you get a to the 1st, or just 16a. 26, multiply the coefficients, so I get 10. Multiply the like bases, that means we're going to add the exponents, so we get -10. Put it over 1. I'm going to keep the 10 where it is. I'm going to flip my x, and the exponent becomes positive. Okay, 27. So I'm going to raise everything to the -3rd power first. There's a couple different ways that you could do this one, but I'm going to do it in this order. So 2 to the -3rd power, I'm just going to write 2 to the -3rd. G to the -3rd, I'm going to write G to the -3rd. Now I'm going to take the denominator and raise everything to the 2nd power. So I get f to the 2nd, G to the 2nd. Now I'm going to do my division. Okay. I can't divide anything into 2 to the -3rd. There is not an f to divide. There's not a base of f to divide the f squared into. So what I am going to do is I'm actually going to rewrite this. I can technically say f to the 0 power because that just equals 1, okay? This right here, 2 to the negative third, f to the 0, g to the negative third, is the same thing as what I had there before because f to the 0 is 1. I'm just multiplying everything by 1, so I'm not actually changing the problem at all. Okay, now that I have that base of f, I can do my division. Keep the base of f, subtract the exponents. So 0 minus 2, you get negative 2. And then now I can divide the g's. Keep the base of g, subtract the exponents. Negative 3 minus 2 is negative 5. Now I can flip, 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 put a 1 in the top. And you could go a step farther because 2 to the third power is pretty easy to figure out. 2 times 2 is 4, times another 2 is 8. So we could write this 1 over 8f squared g to the 5th. Okay. 28, which expression does not have the same value as 3 to the negative second times 3 to the 5th? So keep your base, add your exponents. So we're looking for the one that does not equal 3 to the third. Well, right here, keep our base, add the exponents. That does equal it, so that's not our answer. Power to a power. Keep the base, multiply the exponents. Looks like that's going to be it, but I'm going to check the other options just to make sure I'm correct. Letter C, 3 to the 0 power, that equals 1. Well, 1 times 3 to the third, that's just 3 to the third, so that can't be it. And 3 to the 7th divided by 3 to the 4th. Keep the base, subtract the exponents. That also equals 3 to the third, so we know that B was the right answer. 29, which is 6 to the third times 6 to the 4th in exponential form. Keep the base, add the exponents. Choice D. Which shows 9 to the negative third in standard form. So I'm going to think, put it over 1. I'm going to flip it. Now that I have that positive exponent, I can do the math to solve this. So 9 times 9, 81. 81 times 9, 729. So 1 over 729 would be the correct answer. 31, which shows this in standard form. All right, first thing I need to do is raise my power to the power. So I keep the base of 2. I multiply the exponents, so I get 2 to the negative 4th. Well, now I'm going to flip it. So I get 1 over 2 to the 4th. Now that I have the positive exponent, I can do the math. 2 times 2 is 4, times 2 is 8, times another 2, 16. So 1 over 16 is the correct answer. Okay, if you have any other questions, just make sure you either pop in during access or make sure you come to class with your questions.